Okay, so in the last unit, we spent almost the entire unit talking about one type of motion, and that is motion with constant velocity. Okay, so think back to the last unit. What is another way of saying that an object is moving at a constant velocity? Okay, what does that mean? Okay, so one way of saying an object is moving at a constant velocity is to say that it's basically not moving any faster or slower. Okay, it's moving in a straight line at a steady pace. Okay, it's like, a car on cruise control, right? Okay, now constant velocity is by far the simplest type of motion that there is. Okay, so in this unit, we're going to step it up another notch and talk about a more complicated type of motion. And so to do that, we're going to introduce the concept of acceleration, and then learn how to solve problems with acceleration, both with equations and with motion graphs. Okay, so let's talk about this concept of acceleration in this video. Okay, so on this slide, you can read what the definition of acceleration is. Okay, by definition, acceleration is defined as the rate at which an object's velocity changes. Okay, so acceleration is a rate of change. And if you were to write that mathematically speaking, you would write a lowercase for acceleration, and that is equal to a rate is something that happens over time. Okay, and it's the rate at which an object's velocity changes. Now in the last video, or not the last video, but in the last unit, we talked about how velocity is basically displacement over time. Okay, and so just like velocity is the rate of change of position over time, acceleration is the rate that velocity changes over time. Okay, now the symbol for acceleration, as you can see, is a lowercase a, and the unit of acceleration is what we say meters per second squared. Okay, so as you can see, okay, meters per second squared, we write like this. Okay, meters per second squared, not to be confused with the unit for velocity, which is typically meters per second. Okay, we'll spend a lot of time later talking about the difference between acceleration and velocity. Okay, so if you're trying to wonder like why is the second being squared, okay, you can also think of acceleration, the units for acceleration being meters per second per second. Okay, so in other words, acceleration is a number that tells you how much your velocity is changing by each second. Okay, so we're going to do an example, so hopefully you can understand what I mean by that. But again, acceleration is not the same thing as velocity. Velocity has to do with how fast you're moving, and acceleration does not. Okay, acceleration tells you how much your velocity is changing by every second. So let's take a look at example 0.5, and let's become more familiar with the concept of acceleration. Okay, so let's start talking about the concept of acceleration. Okay, so let's say, hypothetically speaking, we have a toy car, and it's got like a little battery-operated motor inside of it. Okay, one of those toy cars you can buy. And you turn the car on, and then you let the car go from rest. Okay, and let's just say, hypothetically speaking, the car has an acceleration of 0.5 meters per second squared. Okay, make sure you know your units, by the way, because nothing else in physics has the unit meters per second squared. So when you see meters per second squared, your mind should immediately think, hey, that's acceleration. Okay, now as we start, I do also want to point something out. This right here that I'm underlining, this is a key context clue that you're going to see time and time and time again. When an object starts from rest, okay, that means at the beginning of the car's motion, that object is not moving. That's what it means to start from rest, right? That means you start off not moving. Okay, so what we're going to do is we're going to build a table that shows how the velocity of the toy car changes over time, given an acceleration of 0.5 meters per second squared. Okay, so at time t equals 0, that means at the beginning of the problem, okay, at 0 seconds, my velocity is 0 meters per second. Now, how do I know that? Because where it says it starts from rest, again, if something starts from rest, that means it has an initial velocity of 0. Okay, so be on the look for that context clue throughout this unit. Okay, so what do we do with this 0.5 meters per second squared? Okay, does that tell us how fast we're going? No. Okay, again, acceleration has nothing to do with how fast you're moving. Acceleration tells you how quickly your velocity is changing. Okay, so what that means is after 1 second has passed, the car now has a velocity of 0.5 meters per second. After 2 seconds have passed, the car has a velocity of 1 meter per second. After 3 seconds have passed, the car has a velocity of 1.5 meters per second. Okay, so hopefully you can start to see the pattern here. Right, every second that passes, the car's velocity changes by 0.5 meters per second squared. So how would you describe the motion of the toy car? Well, if you look at the velocity is increasing, which is the same thing as saying that the toy car is speeding up. Okay, so here we can see that the velocity is increasing over time, and it's increasing by 0.5 meters per second every 1 second. Right, so that's what 0.5 meters per second squared means as the acceleration. It means that the velocity changes by that amount every 1 second. Okay, so that is the concept there of acceleration. Okay, so now we're done talking about constant velocity for right now. Now we've moved on to acceleration. Okay, so this is not an object that's going at a steady pace. This is an object that might be speeding up or slowing down. Okay, so again, in this case, the object starts from rest. That tells us that the initial velocity is 0, and then the velocity changes by 0.5 meters per second squared. Now, does the acceleration always have to be positive? No. Okay, and we'll see an example of that later on, because your velocity can decrease over time, and in fact, your velocity can even become negative if you're moving in the negative direction. That means that you have a negative velocity. Okay, but again, don't confuse velocity and acceleration. They're two separate things. Okay, so I'm going to erase this right here. Okay, I do want to show you what a graph of this would look like, though. We saw in the last unit, we saw some constant velocity graphs. And on a velocity time graph, a constant velocity graph looks like a flat horizontal line. Okay, when you add acceleration, you get a graph that looks more like this, and notice that the shape of this graph is actually linear. Okay, it's no longer horizontal, it's no longer flat, it's actually linear. Notice this is a velocity time graph. So we're still going to see position time graphs and velocity time graphs in this unit, but their shapes are going to look completely different than what we've seen in the past, because when you add an acceleration, things become different. Okay, so here you can see that the velocity is actually increasing, and in fact, we'll talk more about this later, but remember, acceleration is the rate of change of velocity, and rate of change is slope. And so this graph would actually have a slope of 0.5 meters per second squared. So we'll come back and talk more about that later, but the slope on a velocity time graph actually represents acceleration, because that, again, is a rate of change, okay, which is what slope is. Okay, so hopefully you have a little better understanding of the concept of acceleration there. Okay, so again, make sure you understand the difference between velocity and acceleration. Velocity is a measure of how fast you're moving in a certain direction. Positive velocity means you're moving in the positive direction. Negative velocity means you're moving in the negative direction. Okay, acceleration has nothing at all to do with what direction you're moving in. Okay, you can have a positive acceleration or a negative acceleration, and that doesn't affect which direction you're moving in. Okay, because acceleration only tells you how fast your velocity is changing in a given direction. Okay, and velocity is measured in meters per second. Acceleration is always measured in meters per second squared. Okay. By the way, one other place you might have heard of acceleration, a lot of people, when they talk about sports cars, they say, that the car can go from 0 to 60 in, 4 seconds. That is an example of an acceleration. Okay, because they're saying the car can go from the starting velocity of 0 to the final velocity of 60 in this many seconds. Okay, that is a measure of acceleration, how fast the car can speed up. Okay, so let's just do a few basic calculation examples with acceleration. Okay, using the definition of acceleration. Okay, so take a look at example 1 here on the left. Okay, so example 1 says that a skateboarder goes from 2 meters per second to 8 meters per second in 12 seconds. Okay, Now, seconds is a measure of time, and so I'm going to label that as t. Okay, remember you should always start every problem by labeling your givens. Okay, now if you look at the equation for acceleration that we wrote before, okay, change in velocity over time. On the slide, it wrote that as v final minus v initial over time. Okay, now a is acceleration, of course, and t is time. But now in these problems, we don't just have one velocity, we actually have two velocities. We have a starting velocity, that's vi, and a final velocity, that's vf. So as you're doing these problems, you're going to see more than one velocity, and you need to identify which one is which based off of context clues. So in example 1, the context clue is that it says from 2 meters per second to 8 meters per second. So in other words, it starts at a velocity of 2 and ends up at a velocity of 8. Okay, that means this 2 meters per second, I'm going to label that as vi for the initial velocity. And this 8 meters per second, I'm going to label that as vf for the final velocity. So when I go to plug into this equation, vf is 8, v initial is 2, and then I'm going to just divide by 12 seconds. Okay, and when I do that, 8 minus 2 is 6, and 6 over 12 is 0.5, and the unit is meters per second squared because that's the unit for acceleration. Now the second question is, by how much does the skateboarder's velocity change each second? Okay, so see if you can figure that out. Okay, so the answer to the second question, by how much does the skateboarder's velocity change each second? The answer is 0.5 meters per second squared. That is the definition of acceleration. Okay, the velocity changes by this amount each second. Okay, so in other words, the answer to the question, what is the acceleration, and the answer to the question, how much does the velocity change by each second, those two are the same question. Okay, it's trying to get you to understand the definition of acceleration. Okay, let's take a look at one more example. Okay, the same skateboarder that had vi equals 8 meters per second. Okay, notice, by the way, that vi is now 8 meters per second. In the last problem, that was the final velocity, but now the skateboarder hits a hole and comes to a stop. Okay, so in example 1, they were speeding up, they were going at 8 meters per second, and now that same skateboarder is going to hit a hole and end up stopping. Okay, so now that 8 meters per second is actually vi, here is another example of a context clue that you will see all the time. Okay, there's two context clues you see all the time. Starts from rest, which means that the initial velocity is 0, and if the object is stopping, that tells you that the final velocity is going to be 0. Okay, so again, we're just going to do this basic calculation using the definition of acceleration, change in velocity over time. Okay, now we have a new time that's 4 seconds. Okay, so I'm going to label that as t, and then I'm just going to plug in for v final, that's 0, for v initial, that's 8, and then I'm going to divide by 4. Okay, 0 minus 8 is negative 8. Okay, so that's negative 2 meters per second squared. That is the acceleration, which is the same as saying that the skateboard's velocity changes by negative 2 meters per second every second. Now, does that mean the skateboarder is moving in the negative direction? No. Okay, the skateboarder is moving forward the whole time. Their velocity is still positive the whole time, okay, until they stop, but their acceleration is negative, meaning that their velocity is going to decrease over time. Okay, so again, the acceleration of negative 2 meters per second squared means that every 1 second that passes, the skateboarder's velocity decreases by 2 meters per second. Okay, so those are two basic examples with acceleration. Okay, so pause there if you need to look at that some more. Okay, now take a look at this table and see if you can answer this question on your own. This is example 2.5. Okay, this question says a baseball is shot straight up into the air by a cannon and its velocity each second is shown to the right. Determine the acceleration of the ball and explain the motion of the ball during these 5 seconds. Okay, the second one might be a little tricky, the explanation one, but see if you can calculate, really this should say calculate the acceleration of the baseball based off of what you see in this table right here. Okay, so pause it here and see if you can figure out what the acceleration is and make sure that you include the correct units. Okay, so to find the acceleration from this chart, what I'm looking at is how much is the velocity changing by every second, right? Okay, so the baseball starts with a velocity of 30 meters per second. Okay, so this is VI. Okay, that is the initial velocity. Okay, at time equals 0, that's how fast the baseball is moving. Notice that the velocity is positive because it's being shot straight up. After 1 second has passed, the velocity is now 20 meters per second. So what was the change in velocity there? Okay, well, the change from 30 to 20 is a change of -10. And in fact, it's the same thing from 20 to 10, from 10 to 0, from 0 to -10, from -10 to -20. Every 1 second that passes, okay, the velocity changes by -10 meters per second. Okay, so what I would write is I would say that the acceleration of the baseball is -10 meters per second squared. Okay, now, does that mean the baseball is falling down the whole time? No. Okay, remember acceleration has nothing to do with how fast the baseball is moving, and it has nothing to do with which direction the baseball is moving in. Okay, all that means is that the velocity is decreasing by 10 meters per second each second. Okay, so how would you describe the motion of the ball? Okay, well, if you look, the velocity starts off at 30 meters per second, and then the number part starts to decrease. It goes from 30 to 20 to 10 to 0. Okay, right here, if your velocity is 0, that means the baseball has stopped. Okay, 1 second later, now the velocity is -10, -20, and then it's going to be -30, -40. What does that negative velocity mean? Okay, well, it means that now the baseball is moving in the negative direction. Okay, remember velocity tells you your direction. So if you have a negative velocity, that means you're moving in the negative direction. Okay, so how would you explain the motion of the ball during these 5 seconds? Well, the baseball went up, it slowed down, it stopped, and then it went back down again. Okay, so here's where it starts. As it goes up, it goes slow, slow, slow. It slows down, slows down. At the highest point, it stops moving. Okay, for a split second, it just stays there in the air, turns around, and then starts to come back down. And as it comes down, it goes faster and faster and faster and faster. Okay, that's why you see the numbers start to increase after that. Right, it goes from -10 to -20, -30, -40. Okay, so that's how you would explain the motion of the ball during these 5 seconds. Okay, so hopefully after watching this video, you have a better understanding of the concept of acceleration. In the next couple videos, we're going to be solving problems with constant acceleration equations and with motion graphs involving acceleration. Okay, so it's going to be somewhat similar to what we've done in the past. Okay, but there's going to be more math, there's going to be more equations, and there's going to be more word problems. Okay, so make sure you really understand the concept of acceleration before you go on to the next video. As always, please let me know if you have any questions, and I will see you guys in the next video.